Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for probability. The probability is that it will rain is 0.4. The probability is that Lim will be late for school if it's rain is 0.6. The probability is that Lim will be late for school if it does not rain is 0.2. Find the probability is that. So now we have the situation which is a dependent situation. So my suggestion is to represent the situation in a tree diagram. So let's have the situation rain. So the situation will be 0.4 for the probability if it will rain. Next we have next situation rain complement, which is 0.6. Next, the probability is that Lim will be late for school if it's rain. So here we have the situation late. So the probability will be 0.6. Next, we have late complement. So the probability will be 0.4. The probability is that Lim will be late for school if it does not rain is 0.2. So the situation late. So the probability is 0.2. Next, we have late complement. The situation will be 0.8. So rewrite the situation. So the probability is that the situation is late given that it is rain. So we can express the situation as probabilities for late intersect with rain over probabilities for rain. Next, we have probabilities that late complement given that the situation is rain. So we can express the situation as intersect over the probability for rain. Next, so here we have the tree diagram. Next, focus on the questions. The probabilities that Lim will be late for the school. So kindly refers to the situation where we have late for school. So here will be the reference. So meaning that we are looking for probabilities that late intersect with rain complement or the probabilities that late intersect with rain. So what we can do is to multiply the situation where we have probability of rain multiply with the probabilities for late given that it's a rain. 0.6 multiply with 0.4. The next situation where we have the probabilities of rain complement multiply with the situation probabilities of late given that rain complement. So where we have 0.2 multiply with 0.6. So the probability for Lim will be late for school is equals to 9 over 25 or 0.36. Next, B, it's rain. Given that Lim is not late for school. So here we have the situation. So kindly express the situation where we have the probability for rain intersect with late complement over the probability for late complement. So kindly refers to the situation rain and late complement. So here we have the situation. So in order to find the late and late complement, where we have to cross multiply the situation, 0.4 multiply with 0.4 over the probability for late complement is 1 minus 0.36. As a conclusion, the probability is that it's rain given that Lim is not late for school is equals to 1 over 4 or 0.25. Video, I'm going to discuss the example for random variable. The table below show a probability distribution function of a discrete random variable y. The variance of y is 8. Shows that k squared minus 2k minus 35 is equals to 0. Find k if it is given that k is a positive. Hence, find the value of e bracket y plus 2. So kindly focus on the table where we have the random variable y, 1 and k. Next, we have the probability, where we have 1 over 3 and 2 over 3. Then, my suggestion is to multiply the y with the probability. So where we will have 1 over 3 and 2k over 3. Next, y squared multiply with the probability. So where we will have 1 over 3, k squared multiply with 2 over 3. So we will have 2k squared over 3. Next, focus on the variance of y is equals to 8. As we all know, the formula for the variance, where we have e y squared minus e y bracket squared. So means that we have to sum up this part. So we will have 1 over 3 plus 2k squared over 3 minus, focus on this part, where we have 1 over 3 plus 2k over 3 bracket square. Kindly focus on this part. So where we will have 8 is equals to 1 plus 2k squared over 3 minus bracket 1 plus 2k bracket square over 9. So expand the situation. So where we will have 8 is equals to 1 plus 2k squared over 3 minus bracket 1 plus 4k plus 4k squared over 9. Multiply all the terms with 9. So we will have 72 is equals to 3 multiplied with 1 plus 2k squared minus, where we have minus 1 minus 4k minus 4k squared. Expand the situation. 72 is equals to 3 plus 6k squared minus 4k squared minus 4k minus 1. So rearrange the situation, where we have 2k squared minus 4k plus 3 minus 1 minus 72, 0. So where we will have 2k squared minus 4k minus 70 equals to 0. Divide by 2. So we will have k squared minus 2k minus 35 is equals to 0. And we already shown the situation. Next, find the value k. So what we can do is to factorize the situation, where we have k minus 7 multiplied with k plus 5 is equals to 0. So the value for k is equals to 7. The value for another k will be equals to negative 5. So by referring to the question, find the k if it is given that k is a positive. So here we have k is equals to 7. So now, since k is equals to 7, kindly substitute into the table. So where we have y is equals to 1 and 7. So the probabilities for the y is equals to 1 over 3 and 2 over 3. Next, y multiply with the probability. So where we will have 1 over 3, 14 over 3. So in order to find the expected value for y, where we will have 1 over 3 plus 14 over 3. So the expected value for y will be equals to 15 over 3, where we will obtain 5. Next, the question asks us to find e y plus 2. By referring to the properties, where we have e y plus with e 2. Kindly substitute the situation, where we will have 5 plus with the 2. So e bracket y plus 2 is equals to 7. Video, I'm going to discuss the example for special probability distribution. The mark obtained in an examination follow the normal distribution with the mean 46 and the variance 256. So my suggestion is to express the situation for the variance standard deviation squared, where we will have 16 squared. If the pass mark is 50, find the probabilities that passes the examination. So means that the first one, where we have probabilities that x is greater equals to 50. So what we have to do now, the first step would be standardize the situation. So probabilities that z is greater equals to 50 minus 46 over 16. Simplify the situation. So z is greater equals to 0.25. By referring to the table, where we will have the situation, probabilities that x is greater equals to 50 will be equals to 0.4013. Next, for the second part, if 5% of the candidate get a distinction, So what is the least mark they get? So the question will be probabilities that x is greater equals to d is equals to 0.05. So step number 1 is to standardize the situation, where we have d minus 46 over 16 is equals to 0.05. Next, by referring to the graph, where we have the standard normal, first, locate the z on the left. Then, z is greater than equals to d minus 46 over 16. So in here will be the region. So kindly referring to the answer 0.05. Does it make sense? The answer is no. Because as we all know, the half of the graph is 0.5. So now locate the graph z on the right. So shaded the region. Does it make sense for 0.05? The answer is yes. By referring to the standard normal table, and we have the value for z is equals to 1.6449. So z is equals to d minus 46 over 16 is equals to 1.6449. So kindly rearrange the situation. So d is equals to 16 multiplied with 1.6449 plus with 46. So the value for d is equals to 72.3184. So round up the situation. So the d will be 72.3 marks. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.